Hello and welcome to this higher tier GCSE lesson on sectors and arcs. First of all, you're going to complete this Do Now task and remember to show all of your working. Pause the video while you work through these two questions. Okay, let's check the answers. So the first one we have got here with full working. Notice that they've used words in their answer as well. If you are working out the area of more than one shape, it's really useful to label what each bit is so you don't get confused within your working. So they've labelled that the area of the circle is going to be 100 pi millimetres squared. The area of the semicircle is going to be 200 pi millimetres squared. Those could be worked out as exact values, but we don't want to round too much too soon, only round when you've got to the very end. So we end up with our shaded area is 100 pi, which is 314.2 millimetres squared to one decimal place. Exactly the same working, but different numbers here. So our answer for the second question is 201.1 millimetres squared. Okay, so firstly today we are looking at sectors. So looking at the area of them and the length of their arcs. So we will see what that is shortly. The silver objective is to be able to calculate the angle, and the gold objective is to have a look at problem solving questions. So first of all, a sector is part of a circle. It's bound by two radii and one of the arcs formed by the intersection of these radii with the circumference. The angle is subtended at the centre of the circle by the arc of a sector, and that is known as the angle of the sector. Now, that seems very complicated, so we'll have a picture, a couple of words there, first of all, for a definition. So radii, that is the plural of radius. And subtended, to subtend something means we're going to draw straight lines from the extremities. In this case, that means the radii. So here's a picture that will make much more sense now. So this shape drawn here with the light blue, that is the sector. So what it means is a sector is part of a circle. It's bound by two radii and one of the arcs. So they are the edges of the shape. And the angle here at the centre is created from drawing a straight line from the edge of each arc. If we were to divide our circle into two and have two sectors, we would have the larger sector is called the major sector and the smaller sector is called the minor sector. So if you were given a picture of a circle with the lines in to separate them into two shapes, you've got the major and the minor sector and the major and the minor arc. This will be summarised on the next slide, so you don't need to copy anything down just yet. So since a sector is a fraction of a whole circle, the size of that fraction is determined by the angle that we've got at the centre. And that angle is often written with that symbol. That is a Greek letter called theta. So the angle that we've got is going to be theta out of 360. So that's the fraction of the circle that we've got, due to the nature of a circle being 360 degrees. We've got all the formulae we need there, but we'll look at that on the next slide. So you're going to copy this into your exercise books. So the first thing you need to do is sketch a circle and draw in the sector. You're going to label R for the radius. If you want to write the word in for radius, just to remind you, you can do. And we've also got the theta labelled. Most of you will probably want to write down what that means so you know what that symbol is. So we've got theta is a Greek letter often used to represent angles. Then underneath we've got the formulae. So the arc length, that is working out the length of this section. So that is theta over 360 times 2 pi r. We could also write it as theta over 360 times pi d. You'll recognise both of those parts as the formula for the circumference of a circle. Now, since we tend to only use the radius in arc length and sector area, we're more likely to be using the first formula for arc length. A sector area is theta over 360 times by pi r squared. Again, you will notice that that is the area of a circle. So essentially what we're saying is whatever the angle is, we're taking that as a fraction of the circle out of 360 times by either the circumference or the area, depending on whether we're working out arc length or sector area. So if you haven't got that copied down yet, pause the video just to finish that off. Okay, let's have a look at an example. We're going to copy this one down into your exercise books. So make a sketch. It is a slight curve between A and B because it's a sector. So what we've got, we need to calculate the arc length and the area of the sector from that diagram. So first of all, we're going to work out the arc length. So we've got theta over 360 times by 2 pi r. Substitute in what we know. So we will have 28 over 360 times by 2 pi times by 5. If this is a non-calculator question, or we need our answer in terms of pi, we can then simplify that to 7/9 pi. If it's a calculator question, we can go straight to the numerical answer and get 2.4 centimetres, and that's to 1 decimal place. The area, again, we've got the formula, and again, substitute. So we're going to have 28 over 360 times by pi times by 5 squared. Like before, if this was a non-calculator question, or you need to give your answer in terms of pi, we can simplify this to 35 over 18 pi. Notice that pi is not part of the fraction. If it was going to be, it would need to be on the numerator here. And then if it's a calculator question, or we want a numerical answer, we can have 6.1 centimetres squared. Again, that's to 1 decimal place. Have a go at these questions. Just be careful on question F about the angle that's labelled. Here you are just calculating the length of the arc. So pause the video while you work through them. The answers then, question A, there's your working, and we have 16.8 centimetres squared. B, 62.8 centimetre. C, 219.9 millimetres. D, 7.6 centimetres. E, 26.5 centimetres. F, 377.0 millimetres. Now you must have the 0.0 to show that you have rounded to 1 decimal place and not to the nearest whole number. Okay, looking at the next set of questions, these are now calculating the area of the sector. Again, just check which angle is labelled here. Pause the video while you work through them. Right, let's check answers. Question A is 47.5 centimetres squared, and you can see the working there as well. B, 463.6 millimetres squared. C, 589.0 centimetres squared. Like before, we must have the 0.0 to show that we've done the rounding correctly. Question D, we've got 983.0 centimetres squared. E, 9,959.7 millimetres squared. And F, 36.9 centimetres squared. So that is the bronze objective done. We're now moving on to the silver objective, which is to be able to calculate an angle. So here we're told a sector has a radius of 8 centimetres and an arc length of 5 centimetres. What is the angle of the sector? So the first thing to do to help is to draw or sketch this out. So we can sketch out a sector and label it, and that will really help visualise what it is we need to do. So we know that we need to use the formula for arc length, because we've not got anything to do with area, we're looking at the length. So we're going to substitute what we know. We know the length is 8, we don't know theta, that's what we're going to work out, and we know that the radius is 5. We can simplify that to get 8 equals theta over 360 times by 10 pi. That step could be combined with the next one. We're then going to divide by 10 pi. because we're aiming to get this theta on its own. We're solving the equation. So we now have 8 over 10 pi equals theta over 360. Just make sure that the pi is on the denominator of the fraction. Then the final step to get theta on its own, we're going to multiply it by 360, since that is the opposite of dividing. So this is the calculation we need, and that is what we are going to type into our calculators. So we have got an angle of 91.7 degrees to 3 significant figures. You're going to have a go at some of these now. Sketch the shape, label the diagram and show all your working. Pause the video while you work through them. Okay, let's check the answers. Question A is 6.00 degrees. Now we've got to have the 00 to show that we've correctly rounded to 3 significant figures. You can see the working there, so you know what you need to do. Question B, to 3 significant figures we have 140 degrees. And question C, to 3 significant figures we have 280 degrees. You're going to have a go at this with area now. Now we've not done an example, but the method is the same. Write down the formula, this time for area, substitute what you know, rearrange in a very similar way to solve to get to the angle. Pause the video while you work through them. Okay, let's check the answers. So you can see the working there. It looks very similar to what we had for angles when we were using the arc length. So the angle for question A is 70.2 degrees to 3 significant figures. B is 145 degrees. And C is 320 degrees. And we're now on to the gold challenge or gold objective. So these are problem solving questions and they can be quite challenging. So the pictures look a bit different, there's a lot more words. Read through it really carefully and figure out what it is you need to do. If you need to sketch anything out to help you, then do that. Pause the video while you work through this question. The answer to this question then, we are working out the angle, but this is including all 3 parts, all 3 sectors together. So divide by 3 to get the answer, and then round. It doesn't say what rounding to do, so a sensible rounding would be no more than 1 decimal place. Notice that they haven't rounded at the first part of that, you only round at the very end, otherwise we'll lose accuracy. Okay, next question. Again, work through this, sketch the shape if you need to, show your working. Pause the video while you do it. Okay, let's check the answer. So the area of the large sector, sorry, that's the small sector, in terms of pi, the area of the large sector in terms of pi, and then we're going to subtract them to get the shaded area. And we've got 41.7 centimetres squared. Now you could have written a decimal answer for both of those areas before subtracting, but make sure you don't round until the very end. So you need to write out a longer decimal if you were going to do that. Okay, these are your challenge questions. So you've got to communicate this mathematically. You've got to show really carefully and prove what it is you are stating or showing in these cases. So if you're going to challenge yourself with these questions, draw any diagrams that you need to, show all the working that you need to, and pause the video while you do these. Okay, these are the answers. The working might be written slightly differently to how you've done it. And it might be missing out a few steps of what you've done. But see if you can get the general gist of it. Well done if you've got these. Okay, so we've had a look. We've been able to calculate arc length and sector area. We've looked at calculating the angles. And hopefully we've had a go at being able to do those problem solving questions. Just a couple of questions to finish us off. Sketch the diagram, show any working, and pause the video while you work through them. Okay, the first one. Answer in terms of pi, so just read carefully. So that's going to be 36 pi take away 72. Like we mentioned in a previous lesson, put brackets around that to show that whole expression has centimetres squared attached to it and not just the 72. And question 11, that is 36.5 centimetres squared. Okay, well done with this topic. I will see you next time. Goodbye.